Alright, I'm going to be trying to give you an example of a hypothesis test. We'll work one all the way through. The question is a given coin fair? What does it mean for a coin to be fair or not? Well, in order to be fair, a coin has to come up heads half the time and tails half the time. So we can write that like this. If P is equal to 0.5, and that's the proportion of coin tosses that are heads. If P is equal to 0.5, then we call that coin a fair coin. We'll call that the null hypothesis. The alternative would have to be is the proportion not equal to 0.5. I hope that makes kind of sense to you guys. It makes sense to me. So let's assume that this is true. We're going to assume that this is true, and we're going to go gather some data. Now, I could flip a single coin a gazillion times, but that's going to take too long. So instead, I geeked out and got this probability simulation thing on my TI calculator. So if I press enter here and I go to toss coins, it will allow me to toss a single coin. I toss a coin like this, it comes up tails, and you can see the bar graph shows a tail. If we repeat, next time we do it, we get another tail. The bar graph doesn't change, but really it's actually twice as tall. Let's continue until we get a head. Oh, there's a head. Notice we've gotten two tails and one head, so the bar graph looks like that. I've done 3 tosses altogether. Let's do 50 tosses. So the calculator goes through and tosses a coin 50 times. Some of those tosses turn out to be heads, some of those tosses turn out to be tails. Altogether there are 53 tosses in that whole sample. Looks like we got more tails than heads. I'm going to do it 50 more times so we get a good enough sample size. Alright, so we have tossed the coin 103 times, I think. Out of those 103 tosses, so let's write this up here. N is equal to 103. That means that our sample size is 103. Out of those 103 tosses, if we hit escape and we look at the table, we can see that out of those 103 tosses, we've gotten 45 that are heads. This is the accumulated value for heads. So what we ended up getting was a p-hat. And our p-hat was 45 out of 103. Real quickly, we can calculate what that p-hat is. I'll escape this. Then quit. No, let's go escape. Yes. Now I'll quit. So I can calculate what 45 divided by 103 is. I got 0.437. So my p-hat is about 0.437. Alright, thank you. We'll come back and examine this a little bit more carefully later.